Welcome to the Substitution Podcast. All right, so here's our next problem. We want to take the integral of e to the 3t dt over e to the 3t plus 2. The question to ask yourself is, do you have a function and its derivative together? Every time you have a function and its derivative together, you've got a chain rule. You can undo the chain rule with substitution. All right, so when I pick my u, all right, so my u is going to be e to the 3t plus 2. Make sure you include that plus 2. Its derivative is just going to be 0 anyway, and that way we make our denominator nice and simple. All right, so the derivative of u with respect to t this time, du dt equals e to the 3t power times 3. And then we'll multiply both sides by dt. So du, because I need a du, if I'm going to integrate with respect to u, I have to have a du. Right, so du is equal to 3e to the 3t dt. I don't see a 3 there. All right, so I can't, du cannot stand for 3e to the 3t dt because there's no 3. However, I can divide both sides by 3, and 1/3 du can stand for what we do have, which is e to the 3t dt. And I'm going to pull that 1/3 out right in the beginning. Oops. There we go. Ooh, that doesn't look like a very good 3. All right, so my integral is going to be 1 over, right, du, and I'm not, excuse me, 1 over u, so I'm just going to put du there. Instead of 1 over u times du, I'm just going to put du over u. Right? And now we're going to take the integral of that. Right? So when we integrate something 1 over something, right, that's going to be natural log, right? So this is 1/3 natural log of u plus c. Now we need to replace the u with what u stands for. You put the u in, you got to take the u out. So f of x equals, I'm going to make sure it's a function, because it is. Being a little slow here. There we go. 1/3 natural log. Since e to the 3t plus 2 is always positive, I can really drop those absolute value bars and just use parentheses and then include your plus c. If we want to check our work, we can always integrate. Right? So I'm going to integrate over here. Right? So so we'll integrate. Right, so we're taking the derivative of 1/3 natural log e to the 3t plus 2. So whenever I have natural log of blop, right, it's just going to be 1 over blop times the derivative of blop. Right, so this is going to be f prime of x differentiate, because we're going to check our work. Come on, pen. There it goes. Right? And so we have f prime of x equals, right? So we have 1 over blop. So we'll have 1 over e to the 3t plus 2 plus the derivative of blop. Right? And so blop is e to the 3t plus 2. Its derivative is e to the 3t times 3. And I forgot to put the 1/3 in. That was in there before. Right, because it's derivative, we have a 1/3 in front. So now we'll clean this up a bit. F prime of x equals, so I'm going to have in the numerator e to the 3t. The 3 and the 1/3 will cancel, and we'll have e to the 3t plus 2 in the denominator. So there we go. So notice that's exactly what we have as the integrand. So we can always check our work and make sure that what we have is correct. So the function whose derivative is e to the 3t dt over e to the 3t plus 2, that function is 1/3 natural log e to the 3t plus 2 plus c, because the constant would be lost by differentiating. All right, let's try another one. So if you have questions on these, don't understand something, see me on those. I can work with you in tutoring after school. I can even set a day aside just for calculus after school, and we can work on some of these together. All right, so do you have a function and its derivative together? We do. Be careful, don't choose e to the x squared as your u, because you don't have the derivative of e to the x squared. And I don't need to have, the e's not a problem, it's exponent that's the problem. So my u is going to be x squared, which makes my du equal to 2x dx. All right, and I do have a 2x dx. So this part here, well, not that part. Just let me underline the exponent. This part here is going to be u. This part here is going to be du. So this is u right there. This is du. And then e will stay. Right? We have not covered e, so he stays. So we're going to substitute in. So we have the integral of e to the u du. But that's super easy to integrate, right? That's just going to be f of x equals e to the u plus c. And then replace, actually I shouldn't really write f of x until I get to something that's got an x in it, but e to the u plus c is when we integrate. And then my equation, f of x equals, I'm going to replace the u with x squared. So we put the u in, we got to take the u out. So e to the x squared plus c. There we go. See how simple that one was. And if we take its derivative, e to the x squared would be e to the x squared times the derivative of x squared, which is 2x. And that's exactly what we have there. All right, on to the next one. All right, so here's our integral. We have 2x cubed plus 1, all raised to the 4th power, times 6x squared dx. All right, so first you got to pick your u. And if you've got blop raised to a power, then the u should be blop. So our u is going to be 2x cubed plus 1. That's my problem because I've got an expression raised to a power. All right, so u is going to be that. All right, so now du, right, with respect to x, so du dx is going to be the derivative of that, which is 6x squared, and then, of course, multiply both sides by dx. Du is 6x squared dx. Okay. All right, so now we're going to replace this part here with du, this part here with u, and the 4 stays. So we've got the integral of u to the 4th du, add 1, divide by the same thing. It's u to the 5th divided by 5 plus c. All you got to do now is replace that u with what u stands for. 2x cubed plus 1 to the 5th power divided by 5 plus c. Just that easy. So that's why substitution is such a great tool. It makes a very difficult integral super easy, right? And then we just integrate and replace. Okay. Let's look at another one. All right, so again, I got blop raised to a power. U's got to be blop. All right, so u is 3x squared plus 4. Du dx is going to be 6x. Right, and then multiply both sides by dx. So du is 6x dx. Right, and everything's accounted for except for the exponent, which is no problem. Right, so this part here is du, and this part here is u. So we have the integral of u to the 7th power du, and it's just a power rule. So we're just going to increase by 1, u to the 8th, divide by the same thing, add the constant, and then just substitute back. Right? So f of x equals 3x squared plus 4 to the 8th power divided by 8. And that's all there is to it. All right? Super simple. All right, ready for the next one. trying to watch my sound. I really hope there's sound. So much light in this room, it's hard to see the board. All right, so here's our next one. We have the integral of x squared and times x cubed plus 1 dx. All right, again, we got BLOP raised to a power. This time that power is an exponent, but a fraction, but it's still a power. All right, so we have the integral of, let's choose our u, and then let's replace. So our u is going to be the BLOP there, whoops, and I want yellow. There you go, the u is going to be x cubed plus 1, right? The derivative of that, du dx, would be 3x squared, right? And then multiply both sides by dx. So du is 3x squared dx. I don't see a 3, I only see an x squared. So divide both sides by 3, because we can only cover what's there, right? We can't, du can't stand for something that's not even there. But 1/3 du can stand for what is there, which is x squared dx. I'm going to pull that constant out right in the beginning. I've got u to the 1/2 power du. And now we integrate. So increase by 1, divide by the same thing. 1/3 u to the 3/2 divided by 3/2 plus a constant. Dividing by 3/2 is the same as multiplying by the reciprocal. So I've got 1/3 times 2/3 u to the 3/2 plus c. That's going to give me 2/9. So we have 2/9 times u to the 3/2 plus c, and all I got to do is substitute back. So my function is f of x equals, and u was x cubed plus 1, so that's 2/9 times x cubed plus 1 to the 3/2 power plus c. And there's our function. And I haven't stopped really to do a lot of checks, but you can check any one of these and you'll find that you will get exactly what's under there. Okay, maybe I'll check the next one. Okay? Just trying to make sure that we go over all the problems. The checking is pretty easy, it's just taking the derivative. All right, so and hopefully this is all making sense for you. And of course, you can watch this again. All right, so now let's look at this one. All right, so I've got BLOP raised to a power. BLOP should be RU, right? You got BLOP raised to a power. Let's see. All right, let's see if it works out. All right, so U. Now, sometimes you look at it and you go, I think I know what U is, and when you take the derivative and you look back and you go, well, no, that didn't work out. I've got extra variables there I didn't account for, or does it match? And sometimes you just got to try it again. All right, so let's make U, though, what's in parentheses, because that's a good place to start. X squared plus 6x, take the derivative. So du with respect to x is going to give us 2x plus 6. I don't see a 2x plus 6. Well, let me factor. I see a common factor, though. So let me pull out that common factor, that 2. Well, now I've got x plus 3. Well, I do see an x plus 3. All right, so let's multiply both sides by dx, and let's divide by 2, because the 2 needs to be on the other side. All right? So 1/2 du, that can cover my x plus 3 dx. All right? So this part here is being accounted for with a 1/2 du. The part in the denominator there, right, is being taken care of with u. So we're going to have u to the -2. I'm going to pull that 1/2 out right from the beginning. So I've got 1/2 the integral, and I've got u to the -2 power du. That's all that is. So now see, that's very simple, whereas what we had before was not very simple. All right, so we just increased by 1. It's just a power rule. So 1/2 u to the -1 divided by the same thing plus c. All right, so now let's simplify that out. All right, so I'm going to make that negative 1/2, and the u is going to go to the denominator. So I've got negative 1 over 2u plus c, which means when I substitute back, I'll put it here, f of x equals negative 1 divided by 2 times x squared plus 6x. And then plus c. Got everybody. Okay. So let's take the integral of that one, the derivative of that one to check our work. Right? So f prime of x equal, actually, before I do that, let me rewrite that. All right. So this would be f of x equals negative 1/2 times x squared plus 6x to the negative 1 power. Okay, so we're going to take the derivative. F prime of x equals negative 1/2. Right, so I'm going to decrease the exponent by 1, so that would be x squared plus 6x to the negative 2 power, the derivative of the inside part. So that would be 2x plus 6. All right, so now we'll simplify. All right, so this can go to the denominator. So f prime of x equals, I've got negative 2x plus 6 in the numerator. In the denominator, we have a 2 times x squared plus 6x squared. All right, and then if I factor the 2 out, right, this is going to be f prime of x equals, I have a negative, oh, the 2 negatives cancel out, sorry, because that was a negative 2 moved in front. Oh, the negative, so the negative moves in front. I forgot the negative, so that should be positive, right, because that negative 1 moves in front when we increase by 1. So this would be now positive, and if I reduce that to, that's going to be x plus 3 over x squared plus squared in the denominator. And that's exactly what we started off with. Right? Everyone sees I just forgot to put that negative 1 down. Right? Because when we take the derivative, right, the exponent moves in front, we decrease by 1. Okay. Right, so this one here is a really interesting one. We've looked at sine, we've looked at cosine, and the one we have not looked at is how to integrate tangent. And actually, there is no rule for tangent. We have to be a little creative here, and it is going to involve a substitution. All right, so this is a very interesting one, so paying attention to this. I'm going to rewrite this. I can rewrite tangent using the quotient rule, right, as sine x over cosine x. And guess what? Now this is a substitution because I have a function and its derivative. Now choose your u wisely. If you've got a function in the denominator, your u should be the function in the denominator. Right? So I'm going to choose my u to be cosine x. And let's take the derivative. So du dx equals negative sine x. Well, other than the negative, I have a sine x. Right? I just don't have the negative. Right? I would not want to make u sine x, by the way, because there'd be no way I'd have my du be down in the denominator. So whenever you have a numerator and denominator, hint, make the denominator the u, right? Because the du is going to end up being in the numerator. So I don't have a negative there, but that's not a problem. I'll multiply it by negative 1. So I have negative du equals, and I'll multiply both sides by dx, sine x dx. So negative du is going to take care of sine x, and the u is going to take care of cosine x. So now I'm going to pull the negative out right from the beginning. I have negative integral of 1 over u, right? Because I've got 1 over cosine x. So cosine x is in the denominator, du. Well, what's the derivative of 1 over u? Well, that's just natural log, isn't it? So that's negative natural log absolute value u plus c. All right, so now let's replace that. All right, so I'm going to switch now to f of x equals negative natural log of cosine x. I'm going to keep the absolute value bars because cosine x can be negative, plus c. And natural log can't handle anybody negative. It's a very positive kind of fellow. So can I simplify that? Well, I see this negative in front. And remember, a coefficient in front of natural log or in front of any log is an exponent. So let's move it back. So I've got natural log cosine x plus c, and that cosine x is to the negative 1 power. All right, well, let's simplify that. All right, so that's natural log, absolute value of 1 over cosine x plus c. Well, we can replace 1 over cosine with its reciprocal. So who's the reciprocal for cosine? It's the one that doesn't start the same as it. It's secant. So I can replace that with secant. Natural log secant plus c. So surprise, surprise, you take the derivative of the natural log of secant and you get tangent. How about that? All right. Well, you might not get tangent right off the bat. You might get something that is the same as tangent, though, okay, if we were to take the derivative. Okay. But, yes, indeed, if you take the derivative, you will get that. Okay. Maybe we'll do that a little bit later. I want to see. I'm going to probably end this tape pretty soon. They want a vacuum in here. And I'd like to keep these to 30 minutes. Well, they're not in here vacuuming yet, so I'm going to try and do one. I'm going to try and do this one. And I'm going to do this one 2 ways. This one here, where we had cosine in the denominator, I said you need to make u be cosine. Here it really, really matters. Because if u is sine, there's no way that du is going to be 1 over cosine. It's going to just be cosine, and it won't be in the wrong place. So I'm not allowed to move it to the denominator unless, I'm just doing the substitution. So cosine already is in the denominator. So u has to go in the denominator. But unless it's already in the denominator, I can't just put it in the denominator. All right, so here cosine has to be u. But here, it doesn't matter. So we're going to do it 2 different ways. And you're going to see, this time it doesn't matter. All right, so I have cosine 2x sine 2x dx. Now I could make u the 2x because that's a function. But that wouldn't account for the fact that I have both a cosine and a sine. So I want u, I'm going to make u cosine x in this problem. U is cosine x. So that means, excuse me, not cosine x, cosine 2x. Or 2x. All right, so u is cosine 2x. So du dx is going to be 2, actually negative 2 sine x, sine 2x. And I have a sine 2x. I don't have the negative 2. So let's divide by negative 2 and multiply both sides by dx. So du is going to, excuse me, negative 1/2 du is going to be sine 2x dx. And we do have that. All right, so negative 1/2 du will represent sine 2x dx. And standing in for cosine 2x is going to be u. So we've got, I'm going to pull that right out from the beginning. I always pull those right out so I don't have to deal with them. So negative 1/2 the integral of, and I've got u du. Right, well, that's pretty easy, right? Power rule. I don't care about the cosines and sines anymore because they're not in there. It's just a u, right? So just a u, just like just an x, we're going to increase the exponent by 1. So I have negative 1/2 u squared, and I have to divide by the same thing. So I divide by 2, and then plus c. So that means f of x equals negative 1/4, and I'm just going to put that in the denominator and replace the u right away, and the u was cosine 2x. So negative cosine 2x all squared. I can either put the square like this or the square over here. That's fine. And divided by 4 plus c. Right, now assuming that I have not made any errors, and I do not see any errors on my du dx, I should get the exact same thing when we do this the other way, and we're going to switch. And now sine x is going to be the u. All right, let's see if we get the same thing. And that's the last problem before I switch it. All right, same problem, only now u is sine 2x. That makes du dx equal to, now that's going to be cosine 2x, but this time it's going to be positive. So cosine 2x, and then again times 2, because I have to take the derivative of the 2. And I don't see a 2, so I got to divide by 2. So, and I'll multiply by dx. So I've got 1/2 du equals cosine 2x dx. So now this part here is going to be the du, it's actually 1/2 du, and this part here is going to be the u. All right, so now I have 1/2, now it's positive, and the integral of u to the u du, sorry, forgot what we're writing in there. All right, I got everybody accounted for. U is the sine 2x part, and the 1/2 du is everything else. All right, and now we'll integrate, so we increase by 1. So I have 1/2, and now u, and we raise the exponent, and then divide by 2 plus c, and now we're going to change back. And let's see if we get the same thing. So u is now sine. So sine 2x, and that's all squared, and divided by 4 plus c, and that's f of x. It's not. So I got f of x equals sine 2x all squared, divided by 4 plus c. And f of x is negative cosine 2x divided by 4 plus c. I didn't get the same thing. Well, when I said I would get the same thing, I meant when we take the derivative. So let's see if we take the derivative, do we still get we get the same thing? All right, let's take the derivative real quick. F prime of x equals, all right, so the derivative of negative cosine 2x all squared, right? The 2 will move in front, so I've got negative 2, right? I got to reduce the exponent by 1, so that'll just be the first power. Cosine 2x times 2, and there was already a negative 4 there. And now I have to do the derivative of the inside part. So I did the derivative of the 2x first, but I had to do the derivative of the sine x. I didn't do that part. And kind of wanted to get all my coefficients in there, but I probably should make sure I don't mess you up. I'm going to erase the 2 for now. So the negative was there. What did I do right there for? Oh, I wrote a negative in twice. Sorry. Let me just start this one over, because I skipped a couple steps and I shouldn't. All right, so the 2 moves in front, right? The negative was already there, right? The 4 was already there. Let's put that back there. So the 2 moves in front, the negative was there, the 4 was there. All right, so we have the derivative of blop squared. Derivative of blop squared would be 2 blop. That's our 2 blop. The negative and 4 were already there. All right, now we take the derivative of the blop. The blop is the cosine 2x. All right, so that would be negative sine 2x. And then we have to multiply by the inside part. I was kind of jumping the gun by doing that. My microphone needs to stretch farther, hoping you can still hear me when I have to reach over. All right, so now let's simplify that. So we've got the negative 2 and the negative and the 2 and the 4. That all cancels. So I'm going to be left with cosine 2x sine 2x. Right? And then the plus c, of course, would have just gone to 0. That's what we have there, cosine 2x sine 2x. Let's take the derivative of the other one. All right, so again, I'm going to have f prime of x equals, the 2 is already, the 4 is already there. This one doesn't have a negative in front. So the 4 is already there. The 2 will move in front because it's just blop squared. So that would be 2 blop. So I have 2 sine 2x. Right? And then the 4 is already there. And then I got to take the derivative of the blop. So the derivative of sine 2x is cosine 2x. And then I still have another chain. Oops, another chain. I want to move this a little bit. There we go. So I got to take the derivative of the 2x. So that's going to give me 2. And now the 2's and the 4 will cancel. So I've got f prime of x equals sine 2x cosine 2x. And the very same derivative. So which function is it? There's no way to know. They both have the exact same derivative. So sine 2x all squared divided by 4 plus c has the exact same derivative as negative cosine squared 2x divided by 4 plus c. They're so similar, and really they are just shifts of one another. And so who's the real function? Either one of these could be. They both have the same derivative. So here's kind of an interesting problem. I'm going to end this podcast at this one, and I'm going to pick up with this problem here. All right? So see you in the next podcast. Bye.